All right, in 7.6, we're going to take a look at polar graphs. Okay, so in this first part, we're just going to look at polar coordinates. Now, a polar coordinate, okay, is just another way to express a point on a graph. Normally, we would express a point on a graph using an x-coordinate and a y-coordinate, but in the polar graphing system, we are given an r value and a theta. Okay, so the r value we call a directed distance. Okay, but we can kind of think about this as like a radius. And then theta is just the angle of rotation. So we can actually have a completely different plane to graph on, the polar grid right here. So for example, if I wanted to plot the point to 60 degrees, okay, now we can also represent a polar point in radians. So this same point, would be 2 pi over 3. Okay, you may see degrees or radians to represent the angle. What this means to plot something like this, we would just go out a distance of 2 and then rotate 60 degrees. Okay, so this is where that point would be. Okay, the polar point to 60 degrees. Now, most of the time, we're not actually going to have access to polar graphing paper or polar grids. So we can think about graphing this just on an XY plane as well. Okay, all I would do is say, well, go a distance of 2 and rotate that 60 degrees. Okay, and when we do this, we would be approximating, and a lot of times we can even draw in a line here to show that this has a length of 2 and this angle is 60 degrees. Okay, and that's how we figured out the location of that point. Right? So this is the idea of graphing using polar coordinates. Okay, now polar coordinates are actually not unique. Okay, and an XY point is unique. Right? There's no other way to represent the point 1, 2 on a graph. But there are multiple ways to represent polar coordinates because I can rotate a whole bunch of times. Right? So this kind of goes back to the idea of coterminal angles that we've talked about in the past. For example, if I start with the point 360 degrees, so that means a radius of 3 rotated 60 degrees, well, I could just go a whole nother 360 degrees around and I would be in the exact same spot. So if I just add 360 degrees to this, I would be at the point 420 degrees, and that would represent the exact same coordinate. And I could keep doing that. I could keep adding 360, 360, 360, and I would be in the exact same spot. Or I could go the other way, and I could subtract 360. And if I subtract 360 from 60, I would be at negative 300. I could subtract another 360, and I would be in the exact same spot. Okay? And again, we can do that with degrees, or we can do that with radians, right? So we would add multiples of 2 pi to talk about that angle in radians, right? Now, another way that we can represent polar coordinates in different ways is by changing the sign on r. So in the first slide, I mentioned that r was a directed distance. So if we start, for example, with this point, okay, the point 4, negative 30 degrees, so that's saying I went a radius of 4 and then rotated negative 30 degrees. Well, if I change the sign on r, that just tells me to go in the complete opposite direction. So the point negative 4, negative 30 degrees would actually be up here. Okay, so in other words, right, I just went 180 degrees in this direction. Okay, a negative r just means go in the opposite direction. So if I were given or if I wanted to plot the point -4, -30, I could go to find 430 and then just go in the complete opposite direction, or rotate that 180 degrees, right? Now, to represent the same point using r and -r, I can say that if I flip the sign on r and add 180 degrees, that would be the same point. For example, okay, if we take this original point of 4, -30 degrees, and I flip the sign on r and make this -4, well, I could just add 180 degrees to this, or pi, and I would be at the same spot. Okay? So I can say that 4, -30 is the exact same point as -4, 150 degrees. Okay? So let's go through a full example of something like this, right? Let's say we want to start with the point 2, -150 degrees. Okay, so let's plot that point. So we're going at a distance of 2 and rotating that -150 degrees. So that would end up a little bit more kind of like right here. Okay, so I'm saying that this is a distance of 2 and this is an angle of -150 degrees. Okay, and remember, whenever we're measuring an angle, we're always measuring from the positive x-axis here, right? So now I want to find this point 3 other ways, such that first, my r value is negative, and my angle is between 0 and 360. Okay, so if we think about this, okay, if I want to say, well, I want to have a negative angle, or a negative r, sorry, I know that my r value is going to be -2. Right? And if we think about what we just said, right, if I take the opposite of r and just add 180 to the angle, so if I add 180 to this, I would be at 30. So the point -230 is actually the same as +2, -150 degrees. Right? Now, the next one says, well, keep the r positive. Okay, so I'm still going to have an r of 2, but this time I want my angle to be between 0 and 360. So here we're thinking about a coterminal angle. Right? So if instead I went this way, okay, I'm essentially just adding 360 degrees to -150. So going in this direction, that would be 210 degrees. Okay, so instead of rotating my radius of 2, -150, if I rotate my radius of 2, 210 degrees, I would end up in that same spot. And the final one says I want r to be negative, so I want -2, and I want my angle to be between -360 and 0 degrees. So if I want that, right, so we're saying I'm going to -2, and so we could just look at this one, right, and say, well, find a coterminal angle here that is negative. Well, I would just be subtracting 360 from this, so that would end up being -330. Okay, so again, kind of 2 ways we want to think about finding points like this. The first is that we're just really looking at coterminal angles. So to find another representation of a point, I can just continually add or continually subtract 360 degrees from the angle measure, or 2 pi if we're talking about radians. And the other way is whether my r is positive or negative. Okay? If my r is positive, we are just going out to where it says, right, 2 and then -150. If my r is negative, I would just be going in the complete opposite direction. Right? So now let's talk about converting between polar and rectangular coordinates. So first, if we are given our point in polar, and I'm going to convert to rectangular, we just use these conversion factors. Okay, so the x-coordinate is just going to be r times the cosine of theta. So here, my r is -3, my theta is 60 degrees. -3 times the cosine of 60. Now, most of the time, okay, in these problems that we're given, these are going to be angles on the unit circle. So we want exact values. So use our unit circle. Okay, go to 60 degrees and find the cosine. Remember, cosine is the x value, so that would be 1/2. So here, my x-coordinate is just going to be -3 times 1/2, or -3/2. And then for y, that is r times the sine of theta. So that'll be -3 times the sine of 60. And the sine of 60, if we go back to our unit circle, sine is the y value, so that'll be square root of 3 over 2. So my y-coordinate would just be -3 times the square root of 3 over 2. And putting that together as one coordinate, I would have -3/2, -3 square root of 3 over 2. So this point converted to rectangular coordinates, in other words, an x-coordinate and a y-coordinate, would look like this. Okay? Let's try another example here. How about one where we have our angle in radians? Okay, so let's say, well, x is going to be r times the cosine of theta. So -π/4, if I go to my unit circle, -π/4 is right here. Okay, -π/4 is actually the same as 7π/4. So the x value there is square root of 2 over 2. So my x-coordinate would just be square root of 2. For y, 2 times the sine of -π/4. So if we go back to the unit circle, the y-coordinate there was negative square root of 2 over 2. So this would end up being just negative radical 2, and I can say that my coordinate point, okay, would be square root of 2, negative square root of 2. Okay, so this is the polar representation. This is the rectangular representation of that point. Okay, so now let's go the other way. Let's say given rectangular coordinates, we want to convert to polar. So to do this, okay, just a tad bit more work. Okay, the first thing we want to think about is the quadrant in which our point lies. So if we just think, real quick, -2, 2 square root of 3, right? That's going to be in quadrant 2. So that's going to be important when we get down to this step. So now to find r, right? R is just the square root of x squared plus y squared. So that'll be the square root of -2 squared plus 2 times the square root of 3 squared. So that'll be 4 plus, so this would be 4 times 3 is 12, which would be the square root of 16, which we can say is 4. So we already have our r coordinate, right? That would be 4. So now the next thing I want to do is find the reference angle. So to do that, we're going to say this is the inverse tangent of the absolute value of y over x. So 2 radical 3 over negative 2. So again, when we're finding reference angle, we're taking the absolute value. So the 2's would cancel. I would have negative radical 3, but if I'm taking the absolute value, that'll just be radical 3. So what we want to think about then is, well, where in the unit circle is the inverse tangent equal to the square root of 3? So tangent is y over x, right? So if we think about y over x, square root of 3 over 2 over 1/2, that's actually going to be here, right, at pi over 3, or at 60 degrees. So we can say that our reference angle is actually pi over 3. But now, reference angle, remember, measures the angle from the x-axis. Okay, so this would be my reference angle right here. So that means if this angle is 60 degrees, or pi over 3, the angle that I'm actually interested in is this angle. So if I'm in the second quadrant here, that's where this is important to know that we are in the second quadrant. So I would say, well, this black angle here would be 180 minus 60, or pi minus pi over 3. So the actual angle that I want is 120 degrees, or 2 pi over 3. Okay, so my final answer, converting this point into polar, would be 4 2 pi over 3, or 120 degrees. Okay, let's go through one more example of that. Okay, let's say that my rectangular coordinates are -1, -1. So first, I want to think about what quadrant that's going to be in. Well, -1, -1 is here in quadrant 3. So now, let's find r. So r is going to be the square root of -1 squared plus -1 squared. So that'll be 1 plus 1, which is 2. R is the square root of 2. So now, let's find our reference angle. So reference angle is going to be inverse tangent of the absolute value of -1 over -1, which would just be the inverse tangent of 1. So if we go to our unit circle, tangent, or we want to find where tangent equals 1, that's going to occur here, right? Because square root of 2 over 2 over the square root of 2 over 2 would be 1. So that means my reference angle is pi over 4, or 45 degrees. So again, reference angle means the angle from the x-axis. So that would just be this angle right here. That means that my total angle from the positive x-axis would be 180 plus 45, or pi plus pi over 4. Okay? So my final angle here would be 5 pi over 4. That means that my final answer, converting this point into polar coordinates, would be square root of 2, 5 pi over 4. All right, so again, whenever we're taking the inverse tangent and using the absolute value, that's just going to give us the reference angle. So we still need to think about what quadrant we're in and how much I would need to add or subtract to that reference angle to get the total angle. Okay, so that is it for this video. The final question is going to pop up asking you what questions you have.